Hello, welcome to my tech farm. My name is Igor and I have another laser engraver review video. And this is the Comgo Z1, which is sent to me by the Comgrow company in exchange for a review. Now this laser engraver has the engraving area of 400 by 400 millimeters, and it is able to engrave up to 5000 millimeters per minute engraving speed, which is average, but it is equipped with dual stepper motors on y-axis, which give us more precision and more speed, but I have some suggestions for the design, but more about that later. It can be purchased with 5 or 10 watt laser module. I think this one is 10 watts and it is a fixed focus laser module. This means we don't have to set the focus with rotating some knob or something like that. Instead, probably there will be some distancer and we have to position the height of the laser module compared to the engraving surface. This is much easier and precise method to set the focus of the laser. It should have the square dot laser with the size of 0.08 by 0.08 millimeters. I think I have a method to check that too. Is it really square? But also more about that later. I always like to mention a few words about the safety, so don't forget laser engravers are tools and not toys, so you always wear safety glasses, and not only you but everybody who is in the same room should wear this safety equipment. Okay, now let's see what's in the box. User manual, safety glasses, some protection plexiglass. This is the laser module. There is a fan, a mainboard, and this is the protection glass around it, and I can see it is screwed to the module. I saw a solution where it is removable, it is attached with the magnets. We have some plywood here for engraving or cutting, USB cable, timing belt, tools, zip ties, power cable, memory card with USB adapter and some screws and bolts. Probably these are 4 legs. AC power adapter. The output is 24 volts, 4 amperes. So these are 20 by 20 alloy extrusions, and we have a limit switch here. And these two are 20 by 40 alloy extrusions. And this is the X gantry, and I can see a good thing. This alloy extrusion is 20 by 40, and I suggested this so many times to use the wider alloy extrusion on X-axis, and with this distance between two wheels is a little bit bigger, and it will give more stability, less vibration on the laser module. It's attached to the mainboard unit, and the box is empty. Now, unfortunately, these printed instructions are quite weak. According to this, for example, first step is assembling the frame, but there are no instructions about the position of this alloy extrusion. There is good animation on YouTube, on Comgrow's website, or you can use this video. Okay, so the assembling will be upside down. So here we have 4 holes, 2 smaller are go on inside. Here we have 2 holes, they are on the back side. This one is easy to identify the position. This is the limit switch, it goes here. And here we have the ruler, it goes down, but also pay attention that here we have holes and they are countersunk. Here goes the head of the screw and it goes from the outside. And I have to assemble it using this M5 by 25mm bolts. So it is important to do this on the flat surface, and when you tighten the bolts, press down the alloy extrusion and then tighten them, so with this we can keep this on the flat surface. Then we can turn it back, but put something here to protect the limit switch. Step 2 is assembling the x-axis from the back side. And I will check the tension on the V-slot wheels now. Tension is almost good, but I can feel that I can rotate with my hand very easily this wheel. In that case, I'm using this open-end wrench. I can rotate this exact nut until I don't get that desired tension. And after this, according to instructions, I have to check if this bolt is tight enough. So from this we have the locking nut. I will hold it with this open-end wrench and just to check. Okay, it's good. Same on the other side. And since it is upside down, I can access easily to the V-slot wheel on the x-axis, and I hope it's visible. I can easily rotate it with my hand, so definitely needs to be tight. Okay. The next is installing the main board box, and they will go here on these two holes in the middle, and the logo goes out. Actually, for this, a little bit longer Allen key would be much more comfortable for using. This is from my collection. And same on the other side. Next is installing the legs with these bolts, but we have to use these T-nuts too, because here we have two holes, but on the frame we have only one hole, and on the other place we have to use these T-nuts. It would be much more comfortable if they would prepare here a hole with the tapping, but of course there is a bolt in a way. The solution would be to use a little bit longer legs, and here can be the hole, or maybe they can drill it here in alloy extrusion, so it will be much easier. Anyway, it's not complicated, just not everybody is familiar using these T-nuts. So they have to be prepared in this position. And when you tighten it, the nut should rotate 90 degrees and lock the position. And same with other three legs too. Until it is still upside down, let's install this cable holder, and it will be attached here with the sticker. The next step is the installation of the Y-axis belts. Below the wheel, around the pulley, and below the second wheel. And I have locked the position of the timing belt with this nut and smaller bolt. And interesting, I can see a mark, so somebody already tested this timing belt. And same on the other side, but before I tie this bolt, it is important to pull the timing belt to have good tension on it. Tension is good, and now same on the other side. Now I can install the profile end caps. They're not just aesthetic, but they will also protect us from these sharp edges here. It's time to install the laser module, but first I have to take off the holder. I didn't tie the bolts yet. As you can see, the holder rotates a little bit on the module, so before I tighten it, I wanted to make it parallel, so I will tighten it in this position. As you can see, we have several holes for these screws here, and it depended which position I want to use the laser module. And I will start in lowest position because I want to check are there any vibrations during the engraving. In this case, I will use these upper holes, but later when I want to lift to engrave some higher object, in that case I will use the lower holes. Unfortunately, 4 knobs we have to tighten if we want to move the laser module. I'm not sure if it could be solved with 2 or 1 nut, but okay, I'm sure that this is more stable. Yes, and for the feeling it will be good, because I cannot move so easily this module with my hand, like with those versions where this alloy extrusion is only 20 mm, not 40 like here. Let's connect the wires. I will start with the laser module, And we have two wires, but pay attention because they can be mixed easily. Of course they are marked. So this is the power, and that's this one on the right side, ground and 24 volts. And this is the PWM, goes here on the left side. The X stepper is already connected, so I have to connect this wire on the Y-axis stepper motor. And same on the other side. But this one is from the bottom. And also I'm connecting the Y-axis limit switch. Wiring is finished. Quick check if the cables are long enough to reach every point inside this frame. Okay. And before I give it the power, I always like to use some steel plate just to protect the desktop. And on this I will engrave, and safety glasses are prepared. Don't forget that this laser engraver have limit switches, and with that you can home this position to this corner, and this means that this will be 0,0 coordinate. This is very useful if you want to engrave some, I don't know, products, several products, or do some series with the same size. In that case you prepare some holder on the desk, and you can always set the origin of the laser to the same position. For smaller objects it doesn't matter because the origin is always on the start position of the laser. There's the power cable, and this is the USB cable for connecting with the laptop. Let's set the focus to the top of this surface. I have this 7mm distancer. And the focus is set to top of this surface. The only communication with this laser engraver is over this USB, and it is connected to my laptop. I will use the LaserGRBL software, which is free, but it is available only for Windows. For Mac or Linux users, they have the option to use the Lightburn, which is not completely free, but it is more advanced software. I will turn it on, and then I have to choose the COM port and the baud rate, but if everything is okay, then I click on connect, unlock, and after first try the moving is correct, so it is connected and it's ready for the engraving. I'm loading an image which is with the MTF logo. Well, I will use the vectorize, and now I have to choose the speed. I will try with 2000 millimeters per minute, and I'm using M4 dynamic power. Dynamic power is for the engraving, and constant power M3 is for the cutting. I will leave it to maximum, 20 by 20. Great. With boundary check I can see the edges when the engraving will be, and if everything is okay, then I can click the play button. Safety glasses on. This is with 2000 millimeters per minute full power. Now I can still see some waves from the vibration. As you can see, the module is in the lowest position when the center of mass is far below this alloy extrusion. However, this is 20 by 40 alloy extrusion, and those waves are significantly smaller for those compared with the 20 by 20 alloy extrusion. But if you want to get maximum quality, even here I would suggest you to move the laser module in higher position. Actually, analyzing the images, the difference is not so big, so this 40mm wide alloy extrusion works good, and this is significantly improvement compared to the older 20mm profiles. In next part I want to engrave some grayscale image, and for this I prepared some experiments, and I started with part of the image on 5000 millimeters per minute full power, and it's too dark. Then I tried to raise the speed to 10,000 millimeters per minute of full power, and as you can see it is lighter, so this means that the 5000 millimeters per minute given in the specification as a max speed is not integrated into firmware, so it is able to engrave on higher speeds too. Then I tried on 10,000 millimeters per minute 50% power, and this is on 7000 speed 50% power. So now I will do the full image on 8000 millimeters per minute and 50% power. Let's check the boundaries. I can start with engraving. It's finished and pretty nice result. And all this, even my camera recognizes this is the human face. And it is time to test cutting. This is 3mm plywood, and with cutting I always like to lift the object so I can see the beam on the other side if it is cutting or not. And I will start with 200mm per minute full power. Boundary check. And starting with the grain. Okay, the middle parts fall out, so it is cut and without any problems. I can see some flames from time to time, so definitely an air assist would be very useful with the stronger laser. This is 5mm plywood. Let's see if we can cut in one pass. So in one pass it didn't fall out. And this is what I was talking about, so definitely with these stronger lasers air assist is almost a mandatory. In that case you don't have these flames and a much cleaner cutting. Almost. And one last attempt, 300mm per minute, but with 3 passes. So here you can see the speeds, 100, 200, this is 200 with 2 passes, this is 300mm per minute, but with 4 passes. This is 3mm black acrylic from our earlier experiments, and for 5W laser engraver I need 2 passes to cut this. Properly with this one it should be cut in 1 pass, on 100mm per minute full power. As you can see, no problem, so it was very clean and nice cut here. And I always get that question, can it engrave stainless steel? So let's find out. I have this steel plate and this is from my previous experiments, but instead of engraving my logo, I will start to engrave the initials of the engraver, because it may be confusing, I don't even remember which one is which. So definitely it's here. Let's clean it with isopropyl alcohol. And I can feel that it melted the stainless steel. These two are with 5W laser engravers. This is with 10W laser engraver. I think it was Atom Stack. This is 5W, and this is this Comgrow 10W laser engraver. And I think this is the strongest one. I can feel that it is melted. One last thing I want to test in this video is if I can engrave a stone. I never tried this before, but my wife and my mother like to use these stones as a decoration. So I have here 3 samples for testing, and I will just try to engrave a logo somewhere here. It's not a completely flat surface, but I hope this 1 or 2 millimeters the laser should stay in the focus. After the drying, as you can see, the mark is there, so the logo is visible. Not really what I expected. I'm not sure is this useful to anybody, but I was curious, so that's why I give it a try. I took off the laser module and now I enable the light focusing laser beam to see is it square or not. As you can see, it is a rectangle. So it's not completely squared. And other conclusions, a very decent laser engraver with quite strong 10-watt laser module. And I think in my testing so far this is the strongest, the best for engraving stainless steel. But it couldn't cut the 5mm plywood in one pass. Now usually these 10-watt laser modules use two 5-watt lasers and they combine them somehow, and looks like here we have that combination to be focused in the same spot. Some manufacturers do this to extend the focus length, and we can cut deeper in different materials. Okay, so this is definitely quite strong, but for engraving, for cutting it can do cutting, but not too deep. Now 10-watt laser module is quite big power, and definitely I would recommend using this with some air assist, because if you want to cut plywood or similar, it can very easily catch fire if you reduce the speed. And air assist will improve the quality of the edges, and also it can prevent those flames during the engraving. It is very nice that it has limit switches, so this means that you have a reference 00 point and you can then move to any coordinate the laser module. It is important if you want to repeatedly, you have some serial production and you want to repeat the same engraving on the same spot. And also, I already mentioned that earlier, the only reason why I accepted this review is this alloy extrusion here, which is 20 by 40, and it's really true that I don't have so many vibrations, much less vibrations, compared to those which use 20 by 20 alloy extrusions on the X gantry. There are a few things for improvement. For example, I already mentioned I don't like this cable management, so definitely some kind of drag chains or other solution would be much nicer. 90% of the laser engraver manufacturers insist on this structure here. I'm not sure why. I mean, this stepper motor for X-axis doesn't have to be here on moving part of the module. It can be here, fixed. Of course, we need 2 times longer timing belt, but in that case, this stepper motor is not on the module. Same thing with this on the Y-axis. Doesn't have to be here on the moving part on X gantry. They can be here fixed. And we only need 2 times longer timing belt, and we reduce significantly the weight on this moving part. And with this we can definitely improve the speed of the engraving. It looks like that in most cases the manufacturers don't integrate that speed limitation in the firmware. That is good, I think, because here the specification says maximum is 5000 millimeters per minute, but I could do engravings in 10,000 millimeters per minute, and this is very useful if you want to engrave something bigger, some kind of grayscale image or something like that. So there we really need that speed. About this mainboard box and mainboard unit, I think it's a little bit old-fashioned now, because recently I got several laser engravers which have the screen and possibility for the offline engraving. For me that's important, because usually my engravers are down in the basement and my laptop is here in my flat, and I don't want to bring my laptop with me every time if I want to engrave something smaller. So it would be good if I could just copy the G code or NC code to the SD card, place it here and do the engraving directly from the card in offline mode. I have our smart thing which I didn't like here. When I click the boundary check, I want to see the edges of the engraving, but I cannot see easily the spot of the laser because of this protection glass. It would be much better if it would be attached with some magnets, so I can remove it, and when I click the boundary check I can see exactly the position of the engraving and I know it's correct. I can easily place it back, this protection glass, and start with the engraving. Well, that would be my experience with the Comgrow's new laser engraver. I try to cover most important things. If you have some additional experience, you know, write me a line down in the comment section. Thank you for watching, and happy and safe engraving.